Hello students. So today we're going to be talking about continental drift. Continental drift refers to chapter 3, lesson 1 in the textbook, and the learning target is I can explain the hypothesis of continental drift and describe two forms of evidence to support it. Now, as usual, make sure that you guys are lining up your page. So you've got that top line across that top margin, and then that line down about 1.5 inches on the side, okay? So once you've got that lined up and you've got the learning target right up at the top here, you've written all that, let's move on. So here's a picture that some of you might be familiar with. There's a name down the middle of this picture that you can probably recognize. I know some of you will, but we'll get to that right now. So this is continental drift. So let's start off with this. You don't need to write anything down about him, but this is Alfred Wegener, and we're going to talk about him because he's the one that really kind of summarized the evidence that was available at the time, and so we kind of tell it from his perspective or from his work at that time. So he was born in Germany, he was in the army, and he actually, when he got his degrees, he studied the climate and the atmosphere and the weather, and so what his degree was in was meteorology, and that was actually kind of a newer field at the time to be studying that. This whole new idea of his was presented after in 1912. And so what was that? So this is Wegener's idea. So I've written here Wegener's hypothesis. So get this down as Wegener's hypothesis, and it's called continental drift. So please write that down and maybe underline it as I have. And the basic idea, which you need to get down, is the continents used to be connected together and they've drifted apart. And so that's the general idea. There's more to it. He had a lot of evidence that he put forth, but that's the general idea, that they'd been together, connected, and they've drifted apart. And you guys can kind of see up here, you've got some pictures, a couple pictures of the Earth in different forms. And what you've got going down here is in the beginning, and then the arrow I'm drawing right now is time. So time, as it went on, you can see that the continents kind of changed as they went, and these were actually his original sketches from there. So what was the evidence? I mean, he's got to put forth a scientific theory or a hypothesis. He's got to give some evidence. And so I've listed a couple things here. There was more, but these are the ones that we're going to focus on. And so you're not going to need to write these down right now because you're going to have one for each, but make sure you get this, Wegener's evidence, as a big header, and then we're going to get each of these separately. Now, number one, shapes of the continents. Shapes of the continents, as you can see in this picture right here, you've got these outlines of South America and Africa, and these are the continents that Wegener actually looked at the most. And so right here, please get these bullet points down. Wegener thought that the continents looked like pieces of a puzzle, kind of, that they looked like they'd fit together. And you know, he was actually cutting maps up because he didn't have Photoshop at the time. So he's cutting these maps up, putting them together, and he's like, these are kind of this seems like more than a coincidence that these could have fit together at one point. And so when he was very convinced by the outlines of the continents. And I mean, if you look at this right now, you can see that you actually do have a very distinct outline. That, I mean, these aren't modified at all. These continents could, they have that line that fits together, and these are the continents as they exist today, which would have actually been different in those, in the original days, you know, when this stuff happened, when these continents were together, because they actually were. But this was Wegener's idea. Let's get this down. Now there's no number here because I just want to get you the definition of fossil, and we've talked about fossils. I'm sure you know what fossils are in a general sense, but get this definition down. So a fossil is any evidence of a living thing preserved in rock. And so I'd like you to maybe write something about this too if you want, if you've got a little space at the end of the line, that they can be plants, animals, bacteria, anything that is evidence of life that existed at an earlier time. Here are two fossils. One of them is found in South America and one of them is found in Africa. And so Alfred Wegener is digging through all these maps, he's digging through these geology books, and he finds these, not necessarily these exact pictures, but these fossils. And so if you look at these, you can look at the one on the left here, and you can see its skull. You look at this one's skull. You look at the foot here with the bones, and you look at the foot here with the bones. You can look at the back and the way the ribs are. Now, they're not 100% the same. They are different fossils. They're different specimens. But Wegener looked at this and thought, well, that's interesting that they would have such similar fossils, the exact same species, on separate continents separated by an ocean, because these were not These were not ocean creatures, these were land creatures, or lake creatures, I should say. They were within the continents. And he actually saw that rather than just being somewhere on the continent, that they were actually somewhat connected, that you can, if you put those together still, when those continents were together, that those habitats actually overlapped. Number two, connecting fossils. Wegener noticed that they were identical ancient fossils on separate continents. Okay, so we can see that picture to the right there again. He also identified that if you connect the continents, those maps, that those fossil areas overlap, and that was a big part of evidence for him. And number three, similar rock layers. Layers of rock are formed by weather, climate, or volcanic activity in the area, and generally those are not going to be the exact same over continents, not over big oceans, because you've got so much going on. There's different weather, there are different oceans, there's different day and night times, so you're going to have different weather at different times, different volcanic activity based on where you are in the world. And Wegener noticed that the rock layers were very similar, and if they had actually in fact been together at a point, that they would have had the same, and if it'd be very, very strange for them to have the exact same rock layers if they had been completely disconnected by an ocean. It'd be very interesting, very strange that those would have the same rock layers. So he thought, you know, these must have been connected because they've got the exact same layers. And you can see these layers in here. Glacial till, interesting sedimentary layer, which is basically left over after glaciers. Right up here, you've got some sedimentary rocks. You've got sandstone and shale mixed up. There's, you know, alternating layers. Right here, a layer of coal, which is not a common thing to have. They generally just form in certain places at certain times. And then up here at the very top, basalt lava flows. So those are going to be from actual volcanic activity. Now, one more fossil here. You can see this right here, Glossopteris. Glossopteris was a plant, and you'd find the exact same plant in that area when that was connected. So just like that other animal that we saw before, you saw those connected in the same layers. Now, what was this whole thing called? You've seen this word. This is Pangaea. Wegener said all the continents had been connected, and he called the supercontinent Pangaea. This is an extra thing down at the bottom here. Pangaea is Greek for all lands, and I'm wondering if you can kind of just come up with a quick description. Why is the name Pangaea a fitting name for a supercontinent? It should be, just kind of think about that. It should be kind of an easy response. You think, well, all lands, it's connected all the continents. So that makes sense. I think it's a pretty good name. Now, was his hypothesis accepted? I feel like with all that evidence, we laid out all that evidence down, and the first one about the continent shapes, the second one with the fossils, the third one with the rock layers. There was also climate stuff. So when the glacial till that I showed you, that was actually a good evidence that the climates had been the same, because glaciers don't show up in the exact same spot, and there was a ring of glaciers that actually kind of showed up down here. There was a kind of a layer of glacial stuff that just happened as if a glacier started here and moved outward all the way around. Now, it seems like it makes sense. Was it accepted? No, it was not. People were not buying it. The other scientists were not buying it, and for actually a pretty good reason. With all the evidence, a pretty good reason. They wanted to know, how do they move? You're talking about these big continents moving around. How are they going to be moving? How is something as big as a continent going to be moving around? And he couldn't explain. He couldn't give a good enough explanation. His idea was kind of like, he thought they kind of skimmed around the floor, almost like a hockey puck. So I've got a hockey puck there, but they thought that the ocean floor was smooth or sandy, and that the continents might just kind of slide very slowly. But what's going to make something like that move? And the scientists, the other geologists, were just not having it. They were not going to buy it, and they just kind of dismissed it. They're like, yeah, sure, whatever. The big thing that you guys want to kind of take away from this is there was a mountain of evidence, but if you can't explain all of that kind of came with it and all that would have caused it, there's not really going to be a big part of that that's going to have them backing it up. So the big question that they would try to figure out, I mean, they kind of dismissed Wegener's idea, but what they would need to do to figure out that the continents actually did move was come up with a good reason, a little bit more evidence, and something that could move all those continents. What could be powerful enough to move that much rock, that much land? And they wouldn't even find it out for 40 years. I mean, Wegener was actually dead by the time they figured it out.